All right, take two. So we're live, hey, as you can tell. As I said, global leader of API strategy at MuleSoft. I think this is a kind of a unique topic given the times that we're in. Really, I presented at the API specifications conference last year, but this year, well, it's a whole new year, right? Last year was in Vancouver, which you see behind me. This year we're online. And so, I think we've got a timely topic to bring to you. I'm really happy to be co-presenting with Sanjna Verma, who's a product manager, product leader here at MuleSoft, who's been, she's going to be telling you about the amazing work that she's been doing along with not only MuleSoft team members, but also Salesforce team and Tableau team members. But I think as timely as this is as a topic, it's also sort of a general topic right now where we are, because we're in the middle of this massive data explosion, and I guess we've been there ever since the web took hold. But we've got this incredibly steep curve of data accumulation, which is happening, that we're doubling the amount of data the world's ever produced every year, something along those lines. The graph here just shows you data that's accessible in real time. And at an API conference, what I'm seeing in my role, working with companies around the world on their API strategies, is more and more there's an intersection of data strategy, AI strategy, ML strategy, and API strategy, because it's not so much a problem now to figure out how to collect data, right, or how to try and get more data, capture more data. The problem that people are really dealing with is how to find the needle in the data haystack. How do you find the right insights? How do you combine the information you have? And really, how do you make it readily accessible? And what we're seeing is, although we've kind of grown up with this pipeline of data acquisition and movement, more and more we're seeing data being plugged into core capabilities in real time, being woven into user experiences in real time, being able to, we now have the technological capability to work with all that data at once, combine all that data, synthesize it into inferences and insights. But the way we're now able to start weaving that into our user experiences and core capabilities is through APIs. And really, when I think about the business value of APIs, I often talk about these three stages from Alex Osterwalder about value capture, value creation, value delivery. And we're seeing APIs and data come together in this way where we can use APIs to collect data. We can then have value creating services that are exposed through APIs, and then have those APIs be used to power new digital user experiences. And then we can get this virtuous circle where those interactions that happen as part of the user experiences actually generate their own data, which can then be captured and value created and then delivered. And you get this feedback loop, which is really powering a lot of the differentiating digital capabilities that we have out there. But on this notion of value, I think that one thing to consider with data, and this is certainly something that resonates with organizations that are either collecting a lot of data or trying to access data that's out there in the web, is data doesn't have any value until it's put to use, and that really depends on context. So Peter Morville, who co-authored the Information Architecture Polar Bear book back in 1998, has spent a lot of time thinking about the value of information, the value of data. He had a triangle, or three intersecting circles, talking about users and content and context as being fundamental. But he actually came up with this UX honeycomb that you see in the slide here, that tells you all the ways that information and content and data can be made valuable. And so as we are, I think one of the big challenges we have now in the API space is we've gone through stages of looking at how we can expose business capabilities through APIs, process automation, and so on. But what we really, what we're getting into now is the opportunity to mine that data, to analyze that data, to apply machine learning algorithms, to get all sorts of new value out of the data and expose it through APIs. But when we do that, we need to think about a couple things. Usefulness. Why are people going to be interested in that data? Who are the consumers? What problems are they trying to solve? And usability, right? How are they going to access that data? How can those access methods be optimized for everybody? And so those are some of the considerations that organizations go through when they have data that they want to present through APIs. And I think we've got a great case study here to talk about the experience that Salesforce and MuleSoft and Tableau have gone through in offering a data platform for COVID-19. So love to hand it over now to Sanjna to take us through that story.
Thank you so much, Matt. And hello, everybody. I'm joining you from a very ashy San Francisco, and I hope you all are keeping well. This is totally a very weird time for all of us to be living in. And in particular for us, a bunch of technology aware, what we'd like to call ourselves good Samaritans, wanted to do something for COVID-19. And in particular, we wanted to provide trusted COVID-19 data in a manner to really empower ourselves and understand what is going on. And this is what we were noticing in the landscape. Data sources were saying the same things with different tags or different attributes. For example, they might be saying infected with the WHO or World Health Organization, but the New York Times was calling it sick, which is different than perhaps the CDC. They were calling it hospitalized, but all of these same tags meant the exact same thing, which is the number of people currently affected with COVID-19. So we saw that data sources were saying the same things, just ever so slightly differently. And we needed a canonical way or a standardized way to actually say the same thing continuously. And with the data architects at Salesforce, we devised a standard data model that could actually map each data set's unique attributes in a standardized list of attributes. And this became our data dictionary. Rather than having a dictionary, though, living in a document, which is how it started, perhaps on Google Sheets, we decided to automate it and actually have that entire dictionary delivered and exposed. And the best way we chose to do that was with APIs. And we took those APIs in a manner that could also generate visualizations out of the box. And that's what became the COVID-19 data platform. There was just a tremendous amount of data in circulation around it, and we needed a way to capture those key metrics, such as new cases, survival rates, resource utilization, in a much more automated and operational methodology. So what we did was create a very tightly regulated data pipeline built on a series of APIs, connected to a data warehouse, and then also exposed via APIs and visualizations, such that organizations anywhere could make critical decisions to curb the spread of COVID-19 and curb the spread of the virus and determine the best way to move forward as a community. And this we decided to do at absolutely no charge. It was free, it was open, and anybody could use it. So let me tell you a little bit more about how we actually built this out. First of all, our platform worked by identifying and validating key data sets. We solicited important and relevant data sources that could be added to our global data warehouse. And the platform originally started by getting data from 3 important sources: the New York Times, the European CDC, and the COVID tracking project. And each one of these data sources were validated by domain experts and curated to ensure that all of the information was accurate and reliable. Next, we ingested and normalized the data. The data was fed through a secure application network, which I'm going to take you through in more detail. But ultimately, this was our set of reusable processes. It had an ingestion API, egress APIs, as core connecting pieces of infrastructure. This way, we could also work with partners to contribute data and allow anyone to consume the data openly through the APIs. We also modeled and mapped the data into the data model, and therefore, we're able to store it into the warehouse. And then we were able to consume and distribute it such that all types of people, whether they're data partners, integration partners, other clouds at Salesforce, or data model partners, could honestly get started with this very quickly. So internal product teams, ISVs, and other stakeholders like government agencies, nonprofits, and the public were able to go to any kind of source, whether it was a website like work.com, whether it was an API portal, whether it was the data hub, they could get the COVID specific data and information that they needed and get started in a myriad of different ways. So let me actually take you through this because this is a really interesting journey for us. Let's first start and see what data gets curated in. First of all, we were looking at 3 different types of data, and knowing what the data was really important in understanding how we would expose it. We had public health data that was being reported several times over. This is infection data, testing data, observations and symptoms. There was other public data such as non-pharmaceutical intervention, aka what government policies like travel restrictions are currently in place to curb the spread of the virus. And lastly, medical resource data. How much PPE or ventilators are there? What's the hospital capacity in your area? And we realized the reason why this data was relevant was because it was relevant based on your geography. You wanted to know where you were based on the county or state that you lived in, or maybe your loved ones did. So knowing that, we had a few different things to do, including how we chose the API protocol and the API architecture. We knew that we wanted to choose between different types of web services, and we chose REST because, the operability of different specification types could evolve. It started off being RAML based, and then we could have it based on OAS. We also knew that we were being driven with simple, instead of simple functions, but we really had complex data. The next part was having an OData API, such that we could use it for ourselves internally and connect it to our own different systems. And lastly, we wanted to evolve the data because with every new data source that we got 100 new or 100-ish new attributes. That meant we've had over 250 different column names alone in this warehouse. And knowing that it's grown from a few kilobytes to a few hundred gigabytes of data, having a GraphQL API is going to be extremely advantageous for us in the future. So we know where we're going with this. And we wanted to go there after we could first prove out our first few iterations of the REST APIs. The other really important thing was how we considered the flow of data. Data would be coming in as a JSON or a CSV, processed as a Mule message, and then we chose to expose the data out as a JSON. And we knew that from previous experiences that XML processing can be heavy. And unless we were going to go with a SOAP service, we weren't going to be using XML to expose it. So instead, we chose JSON to ensure that it could be very quick to read, human readable, and it could also be quickly automated upon so that other people could build what they needed to using this data and information. So next, we get into the actual application network where we had the following rules: maximize open consumption and broaden the expectations of your API's availability and usability. We also wanted to make sure that it was available 24/7. So we chose a cloud-first deployment. So this is how we started. We took an API-led approach to how the data actually entered. By first going into the system layer, we were actually able to connect to every single data source. And these data sources were living in GitHub. They were living on the company's natural own download as a CSV process that had to be constructed manually. They were also available as a JSON format on the company's website. So we had to figure out how to actually go and retrieve it. And that was the tricky part of the system layer. We didn't own any of these systems. The next part was, after getting access to the data, we also needed to put it into a data warehouse. For us, our data warehouse, we used Snowflake. And that helped us continue the rule of having everything globally available and cloud first. And then lastly, we needed to ensure that the processes were universally available and repeatable. So everything needed to be mapped into the standardized model and then queued up for delivery back into the data warehouse. We didn't want to always be pummeling it and making our calls very expensive and taxing on the system and service. Lastly, we created what was called the data contribution API so that we could force restart grabbing all of the data on a daily basis. This was all queued up for us and ran multiple times a day. That way, we wouldn't overwhelm our systems, but we always had the most up-to-date data almost as soon as the data sources published them. So when we were defining and designing this ingestion pipeline, we took the API-led approach to building all of our APIs. And we made sure that we could have all of these reusable components. In our case, we took data in, and we designed API specifications, and we're also able to templatize each of these specs. This included standard HTTP response messages, error messages, authentication behaviors, and we were able to define an error structure really easily because we had a custom error handling module that we could use here. And every single fragment, as a result of it being reusable, meant we were able to move 3 times faster for ourselves. At the end, with these data sources, we had 15 specs built, 2 fragments that were reused against every spec, and 1 master library that had the canonical data model and respected the rules of this global data dictionary. So when we moved forward into implementation, it took us 3.5 weeks to implement the entire data pipeline. 65% of our time was spent on nailing the data transformations. Again, it needed to be human readable. So if we couldn't read it right off the bat, it wasn't perfect. The other 1/3 of our time was spent on acceptance testing and making sure that people could actually get to the API and use it really quickly. And that was hard for us in the beginning. We couldn't actually figure out where we needed to reuse certain transformations or where we needed to utilize more readability. People weren't technologists that were coming to our platform. So we were able to utilize some benefits right out of the box, like having streaming. And we were having a huge amount of data, and this helped us consolidate our resource utilization. Next, we used data weave to transform everything into human readable formats. And then we tested whether or not connections were being made to the sources, whether the application logic blocks were actually correct. And we built out our own custom user acceptance testing blocks of APIs as well. This was able to help us ensure that data being ingested from the raw source was in the correct format and mapped correctly. That's when we were able to finally get into this format. How could we have it exposed? Well, deploying the API so everything could be exposed was also difficult. We ended up deploying our APIs, but that didn't mean going live with the entire platform. It was more clicks than code, but it was still a lot of context switching, and we ended up rolling back twice. Now, why did we roll back our APIs? We needed more testing and quality control on the data comparisons, and we compared the outputs via the API response and the visualization to make sure that each thing was saying the same thing. So whether you were looking at text code in JSON format, or looking at the visualization on a map provided by Tableau, it needed to say the exact same thing. And so as a result, dual usability was a paramount issue for us. So lastly, we looked at the behavioral changes that were going to come. We published a live API implemented endpoint to Anypoint Exchange. It didn't have any sort of credentials that you needed in order to actually use the API. So we had to nail how to engage or publicize our APIs and ensure that it was usable. And many of the challenges in going live, including how the user could actually understand and use the API and then read through the documentations, were really applied over here. The first time we went live and then had to roll back, we realized that our open API actually forced users to request access. That didn't really mean open to us. Then when we pushed the live implemented endpoint, we realized that wasn't being shown by default. So every time we went through this exercise, we did a better job of reviewing the artifact and the API itself. And we had to ensure that everything was not human readable for a technologist, but human readable for somebody like a teacher, a government agency, or another company who didn't know our dictionary but needed to get through there. And the verbiage on the API portal had to be really clear and very succinct. So in the end, since we've gone live, we've been able to survive a minor DDoS attack. It was very cool to know that we had an API that even wanted to be hacked. Then we've been averaging about 600,000 unique API requests a week since we've gone live. We've averaged 30,000 visualizations or views to our visualizations. And we've been able to see how our API-led approach in action is applied and where the majority of these requests are coming from. We've seen hotspots in usage across APAC, in Latin America, parts of Europe, and the US. So our pipeline started off like this, but within 3 months, we were able to grow it to include over 16 data sources. Our API-led approach started like this in terms of our architecture, but after revising it 7 times over the course of 4 weeks, we were able to grow it like this. Overall, our lessons learned here is that having themed specific data curated for global analysis and visualization is incredibly important. We also were able to create and build a system from scratch that didn't exist. And making sure that contextualized data out of that system was readable, was consistent, and was available was incredibly important for us. So we've learned that there's a huge opportunity here to make sure that things are human and machine readable. They're available for anybody at any point in the world 24/7. And making sure that we weren't just proprietary and servicing our own needs, but making sure that anybody in the general community, technologist or not, could use this. I realize we've gone a little fast. However, this was an incredible resource for us, and we've learned a lot in the process. So thank you for joining us today.
Thanks, Sanjna. I wanted to add one thing, if we're, if I can. I just think that there's so many angles to this story, in that, you know, there's the urgency of the COVID data. Like, I think everybody gets, I don't think there's any question people get, yeah, it's important to have this data. But I know a lot of the work that continues to go on is really about understanding who are the consumers and learning from the consumers and having that shape the product offering. I think it's really interesting to see the shift in perspective from being a tool provider in the API space to being an outright API product provider. So, you know, I'm really glad that you had the opportunity to share the story with the community, because so many of these perspectives and topics are so important. So thank you, and thanks everyone for joining us, and hope you enjoy the rest of this awesome event.